Now we shall discuss question number 6. The length of the top view of a line parallel to VP and inclined 45 degree to HP is 50 mm. One end of the line is 12 mm above HP and 25 mm in front of VP. Draw the projections of the line and determine its true length. Okay, so in this case, it is mentioned about the line. The name of the line it is not given. So let us take the name of the line as line AB. Let us take it as line AB. So the length of the corresponding top view is mentioned as 50 mm. The line is parallel to VP and inclined 45 degree to the horizontal plane. And one end of the line is 12 mm above HP and 25 mm in front of VP. So let us take this particular end as end A. Okay, we are assuming that the line is named as line AB and one end is A and that end is 12 mm above HP and 25 mm in front of VP. So draw the projections of the line and determine its true length. So we had to find the true length at last. So the value of theta, that is inclination with respect to the horizontal plane, it is given as 45. The length of the top view is given as 50. The line is parallel to VP also. So whenever a line is parallel to VP, what will be its top view? Its top view will be a straight line parallel to the XY line. Okay, so whenever a line is parallel to VP, its top view will be a line parallel to the XY line. So first, as a first step, what we shall do is we have to draw an XY line here. So already have drawn an XY line here. Now we shall mark the coordinates of the given point. So here the line is named as AB and let us take one end as A and let us assume that end A, this one end, let us take it as end A is 12 mm above HP and 25 mm in front of VP. So first let us mark those coordinates. So 12 mm above HP. So let us mark this point as point A dash and 25 mm in front of VP. So 25 mm in front of VP. So let us mark the next point. So let us mark it as A. Now let us draw two reference lines which are parallel to the XY line, one through A dash and another one through A. Okay, let us draw two reference lines. This reference line, it will be useful for us in the later steps to solve the problem. So we shall draw two lines, two thin lines, type B lines which are parallel to the XY line. Now, in this case, the length of the top view is given. The length of the top view is given. So, what is the length of the top view? The length of the top view is 50 mm. So, as the line is parallel to VP, definitely its top view will be parallel to the XY line. And this particular top view is having a length of 50 mm. That is what it is mentioned in the question. So, let us draw this 50 mm length through this reference line. Starting from A, let us draw a straight line, a continuous thick line as the top view of the line up to a length of 50 mm. So the other end of this top view, we shall mark it as point B. So this is the top view of the line which is measuring a length of 50 mm. It is measuring a length of 50 mm. Now we shall think about the front view of the line. Okay, front view of the line. So as we have seen in the previous problems, always the front view and top view of the same points will be on the same single projector. Here if you notice, A dash and A, they are along the same projector. Is it? A dash and A, they are along the same projector. This projector is perpendicular to the XY line also. So where will be B dash located? Where will be B dash located? So here I have not drawn the projector of B. Let me draw a projector of B here, perpendicular to the XY line. So this is projector of B. Let me extend it further above this XY line also. So our point B dash will be somewhere along this line, but we don't know exactly where it is located. Is it? We don't know where exactly it is located, but we know this line, this projector, somewhere along this projector we have got our point B dash. Okay, now the next value or the next dimension that is given to us is the angle theta, is it? So the inclination of the line with respect to the horizontal plane is given as 45 degree, and the line is parallel to the vertical plane. So when you're observing in the front, when you're observing from the front, definitely you will be able to see the true length in the front view. Definitely you will be able to see the true length of the line in the front view. Here the true length is unknown to us. We are asked to find out the true length. And along with the true length, you will be able to see the angle also, the true inclination of this line with respect to the horizontal plane, which is 45 degrees. Okay, so what I am doing as a next step is, starting from point A dash, I am drawing a 45 degree line up to this projector. Okay, so let me take an angle of 45 degree using the protractor. Now connecting A dash and this 45 degree point, let me draw a thick line, continuous thick line. So this will be the front view of this line. This angle is 45 degree, and what will be the name of this end? This end is end B dash. Okay, this end is end B dash. So this end is A dash and this one is B dash. So now let us mark the dimensions, and towards the last we shall find the true length also. Now this is the true length of the line. Why this is the true length of the line? So this is actually our front view. This front view will be having true length. The reason is the line is parallel to VP. So whenever a line is parallel to VP, you can see the true length in the front view. So let us measure what is the true length. It is approximately equal to 71. You may get it, maybe some of you may get it as 70, or some of you may get it as 72 also. Approximately the value is 71. So depending upon the accuracy of your drawing, there may be some difference, minor difference between the answers. And if you want to find this length trigonometrically, you may get the exact value. But here we are not supposed to find the true length using the trigonometric equations, because here we have to solve the problem graphically. Okay, so here I have measured the true lengths, and I have to write it to the bottom side of the corresponding figure onto the right hand side, and towards the bottom side somewhere here you have to write the true length of the line as 71 mm. You need not write the units here, because by default we are considering all dimensions are in mm. That is why we don't require units here. So now let us compare this problem with one of the previous problems, that is problem number 4. Okay, we have got a similar problem. So in problem number 4, we had the true length of the line, we had the inclination of the line, and then we proceeded to the top view. Is it? We started from this diagram, that is the front view, then we proceeded to top view. So in this case what we are having is, we know the top view and then we proceeded to the front view. Okay, so that is the difference between problem number 4 and problem number 6. Here we started from the front view, then we reached the top view. Here we started from the top view, then we reached the front view. So the important point that you have to remember here, always the front view and top view of the same points will be along the same projector. Here also always the front view and top view of the same points will be along the same projector. So this logic we have to take into account in order to solve this particular problem. So that is about problem number 6. Now we shall consider problem number 7. The length of the elevation of a line PQ, which is parallel to HP and inclined 30 degree to VP, is 60 mm. That means the length of the front view. Elevation means the front view is 60 mm. The end P of the line is 20 mm in front of VP and 25 mm above HP. Draw the projections of the line and find its true length. So in this question also true length is not given. We are supposed to find it out, but the length of the front view, that is elevation length, is given as 60 mm. So what are the other data that are related to this particular problem? So here the line is parallel to HP, is it? So whenever a line is parallel to the horizontal plane, what about its front view? Its front view will be a straight line which is parallel to the XY line. Okay, so whenever a line is parallel to the horizontal plane, its front view will be a straight line which is parallel to the horizontal plane. So here the line is having an inclination with respect to the vertical plane. So definitely in the front view you will be getting a reduced length, and you will be able to see the true length only in the top view. So here true length is not given. If at all true length were given, we could have drawn the line directly as we have done in question number 5. So here already I have started with an XY line. So as the next step, we shall mark the coordinates of this line. This line is named as PQ, and we shall mark point P. So P is located. Where is P located? End P is of the line is 20 mm in front of VP and 25 mm above HP. So first we shall mark the coordinates of point P. So P is 20 mm, the end P of the line is 20 mm in front of VP. So in front of VP means it will be below the XY line when you are converting it into a 2D setup. So 20 mm below the XY line, let us mark point P. So this will be point P, and 25 mm above HP. So 25 mm above HP means when you are observing from the front, you will be able to see the front view of point P above the XY line as P dash. So let us mark it 25 mm above the XY line. So this point, let us mark it as P dash. So always the front view and top view of the same points will be along the same projector. So as the next step, we shall draw two reference lines, one along P, another one along P dash, which are parallel to the XY line, and these reference lines may be helping us to solve the problem further. Reference lines are drawn as thin lines, continuous thin lines. Now we know that the elevation length of the line is 60 mm, and as the line is parallel to the horizontal plane, definitely its front view will be parallel to the XY line, and already we are having that the length of the front view is 60. So directly we will be able to draw the front view of this line, which is P dash Q dash, on this straight line. So this particular straight line, now it is parallel to the XY line. Okay. So we shall draw the front view directly in a length of 60 mm as a continuous thick line. So where will be the top view of point Q located? So this is Q dash. Now we have to locate the top view of point Q. So it will be below the XY line, but exactly where it is located, we don't know about it, but we are having a clue. always the front view and top view of the same points will be lying along the same projector. So we shall draw a projector from point Q dash vertically downwards, and somewhere along this projector we will be able to find the top view of point Q. So this is also a continuous thin line. Now, as the line is inclined to VP and parallel to HP, you will be able to see the true length in the top view. Whenever a line is parallel to HP, definitely you will be able to see the true length in the top view, and also you will be able to see the true inclination in the top view. In this case, the inclination with respect to VP is mentioned as 30 degree. So as our next step, what we are going to do now is, we will be taking an angle of 30 degree with respect to this reference line, and we will be drawing a continuous thick line such that it is just touching this projector which is extended from Q dash, and on the particular meeting point you will be getting the top view of point Q, which is represented as small letter q. Now we shall take an angle of 30 degree using the protractor. Now we shall dimension the diagram. Now as a final step, what we have to do is we have to find out the true length of the line. The true length of the line can be measured by measuring the top view of the line. This is because the line is parallel to the horizontal plane. Whenever a line is parallel to the horizontal plane, you will be able to see the true length in the top view. Now we shall measure the length of the top view. So the length of the top view is approximately between 69 and 70. So I am writing it as 69. Sometimes you may get it as 70 also, sometimes you may get it as 68 also. It depends upon the accuracy of your drawing. And if you are calculating it trigonometrically, you will be getting the exact value as maybe some 69.5 or 69.3. But here we are allowed to make a difference of around some 1 mm. Okay, so I am writing it as 69. You need not write the units here because by default each and every dimension in this diagram, it is in mm. So this is having a similarity with respect to the question number 5 that we have already done. So in question number 5, what we have done is we started with the top view because the angle was given and the true length of the line was also given, and then we proceeded to the front view. But in this particular question, that is question number 7, we were not given with the true length of the line. So we were provided with the length of the front view. So we started with the front view, then we reached the top view. That is the difference between question number 5 and question number 7. So the true length of the line, it is also equal to the length of the top view, which is PQ. You can also write it like this. So true length of the line and length of the top view, they are one and the same because the line is parallel to the horizontal plane.